Someone gave me this question to solve, and in this question we have an equation of a curve right here, and we are meant to find, the first question is for us to find the first derivative, which is dy over dx. So this is the first derivative, very simple to get. The second question says we should find the coordinate of the stationary point on the curve and the nature of the stationary point. Now, stationary point is that point of any curve where the slope is 0. Okay, so to find stationary point, the first thing you have to do is you have to equate the first derivative. What is the first derivative? Dy over dx. You have to equate the first derivative to 0. Then when you equate the first derivative to 0, you can easily get your x and your y coordinates. When we have equated dy over dx to 0, you can get x and y. If you get x and y, but how do you understand the nature? Now, the nature is conditional. You have to find the second derivative. The second derivative, which is the squared y over the x squared. So it's your job now for you to get it. When you get it, if it's positive, it is called the local minimum. That's the nature of the point. If it is negative, then it is called a local maximum. Let's go. The question C says we should get the equation of the normal at 2, 2. Now, for us to do this, we need to get the slope of the tangent at x equals to 2, because that is what we were given. So when you get the slope, you put it into the equation of the normal, which is, I'll write it on the board there. So this is what you do. Obviously, this is the equation of the normal at any tangent. So this is it. This m is the slope. It's called the slope, and I calculated the slope by putting my x equals to 2 at my slope. Slope is the y over the x. If you know what slope is y2 minus y1 all over x2 minus x1, which is change in y over change in x. So change in y over change in x, which is the first derivative. So when you get that, you put your slope, you get your slope. Now this your slope, you use it here, right? So when you get here, when you expand and rearrange, this is your final equation of normal. So bring more questions to me. Let's solve and see you in the next video. Bye.